refresh the screen. I forget where my own live stream shows up when I'm trying to look at it myself. It's not in there. I'm just waiting a few seconds in case anybody joins in. Other than that, I'm just recording live instead of doing clips and editing. Just haven't had the time for that. Let's go home. Here we go. I have to pause. Oh, okay, got it. Just want to make sure that the text is pretty clear when I hold it up. I'm on the downstairs freaking router here. So got one person jumped in there. So just gonna do a little update of another little piece of hardware I built for the water heater controller. Not the hybrid water heater controller that I took apart because I realized that given the small size of the rotary compressor and putting it in that big cabinet just wasn't efficient at building up heat to heat my water. And the goal was to run the one compressor off my inverter to both cool this room in the summer when it needed to be cooled, then use that same compressor to heat, sometimes at the same time. But man, it sucked for heating the water when I moved it over there. So might have been able to do some other little tweaks to it to get it to work a little better. But anyway, we needed the water heater to work because it's dead winter. And people didn't like it when it wasn't heating well. So I took it apart, put the compressor back on that apparatus that's outside like I originally had for a couple seasons. So I made this whole new controller in here now. I have to kind of get that adjust its lighting for the LCD there. And I know it's just saying stand by my temperature. Sometimes live, it doesn't like to focus on that thing. But basically reading the coil temperature and liquid line temperature. So the reason for those two thermistors is this time because that little thing hanging on the wall out there, it does freeze up every now and then, and I'd have to catch it manually and turn it off and turn the breaker on to heat the water heater with the stock strip heaters that are in there. Hey, what's up? HVAC overtime. See. So this is just to try to do a couple things automatically and not to give up on the projects altogether. So I've still been adapting over from that Pick Basic Pro to the C language. So I'm getting a little better at it. So what I have here is I got the pump, I got the heat pump section outside. And so I just have a controller. It's underneath that LCD there. And then I got the 4 relay output. Basically, wound up only using 3 of the relays now. But so I got a compressor, which just turns on a relay, which gives 120 volts out to this plug to the outdoor unit. And then I got, I'm using 2 relay outputs. One, it's just simply going through this little freaking light dimmer, using it for the, the triac control, like a, wave clipper just to slow down the pump. And then the second relay just bypasses that basically, and then the motor goes to the full set speed on the pump. And something I'm doing, which actually is helping, is that basically when I have a thermistor in here against the tank that turns on this little thermostat here, and then it tells it just to heat. So it used to just turn on the compressor, turn on the pump, and then it draws water from the bottom, goes to the heat exchanger outside, and then comes back to the pump and then back in the tank up here towards the hot side. When you're taking hot right over here, your cold goes through a dip tube in water heaters, and they put the cold down there. Well, interesting thing, especially when it's cold and our groundwater gets into the 40s and 50s, is that really cold water shoots right there. It would shoot right in there and go through a heat exchanger. And if the performance of the compressor and just at the moment wasn't all that great, it seemed like it actually initially dropped a little bit of the temperature of the water it was in here when it was basically mixing it up, but it wasn't adding much heat to that cold at first. And the hot water, step back. If you were taking a shower, the water heater wouldn't be on, but when it's dropped down to where it turned on, once it started pumping that water, that cold water would only pick up so much heat before it dumped back in here. So it almost dropped the temperature near the outlet a little bit. I mean, you're increasing the temperature down there, so it isn't like you're losing heat, but it was still just kind of weird. So an improvement is that with the liquid line sensor on the liquid line out there, I kind of have the pump not even turn on at all until it hits like over 100 degrees on that liquid line, and then it kicks the pump on low, and it's think of a thermostat going on off on your car, control the temperature in your engine through the radiator. And even some boilers do that. They actually have an actual thermostat in there. That way it pulses the water, into its loop, just so it does to maintain a minimum heat rise. So I'm actually doing that via controlling a pump. So it's like controlling the heat rise. Actually been tinkering on it for a couple of days, and it's actually working. It's actually pretty cool. So it'll kick this on low, and you'll get like a surge of hot freaking water. Because let's say that water was 50 when it was in that loop before it started. It would heat that up and it would keep my liquid line temperature and pressure pretty low until it built up and heated up that heat exchanger loop out there, and then the pump would kind of go on low. Yeah, that little surge. So when you put your hand here, man, you get a surge of really hot water. It's kind of cool, and then it'll start dropping down, and it kind of drops down pretty linearly with the temperature of the liquid refrigerant, where I place the thermistor out there, and then it actually will kick the pump back off. And that's if the water heater got pretty cold. Once the water heater is kind of warm, it usually has that water returning in there isn't ice cold, and it kind of, or once the water heater is actually heating back up, it'll kind of like not need to cycle the pump anymore. It'll actually keep it on. And actually at one point, once the whole tank kind of gets full of hot water, it'll step up to the higher speed. So that's kind of cool, because I used to kind of like play with this speed switch and turn it down in the real cold winters, but then when it was warmer out, it was almost like it wasn't fast enough, and then you'd be having high head pressure. So now it's automatically switching. So anyway, I've had kind of a cold, so I'm kind of worried it's me hacking a lot, but kind of got out of control here. So I just have some this C code. I've been tinkering on it. I have all these different functions. So pump control. Basically, I have my operating modes. I have my main operating mode, which is 0 is off, 1 is when it's heating, and 2 is defrost. Well, I also have pump control modes, and I have being 0 is no pump, 1 is low, and 2 is high. And these just set the thresholds based on liquid line, temperature. If the thermistor is higher than the high set point, if you have 2 set points, then it's in high speed mode, basically pump mode 2. If it's between those ranges, it's going to be in mode 2 or mode 1, which is just the low speed. And if it's below the set point minus that differential, it's going to be off again. So and then this decide the cases, which is 3 cases basically, is how it breaks up. It's going to display, what's going on, and it's also going to control my assigned outputs on the microprocessor, P1 and P2, which is the outputs on the thing. Oops. I was going to get some papers here, but I think I dropped these, all fell off, so they're all out of order now. Let's see if I can find one of them. Yeah, so button inputs. This is kind of how I laid out my thing. It is cool to just print these out now and have an actual schematic for my own circuits. So LCDs. So yeah, there's my compressor output. Pump 1, 2, 3. As I said, I was going to try it as a 3-speed, but I only doing a 2-speed now. And you just basically just map, the port pins and then assign them a variable name, which is I just call it P1 and P2, and it was P3, and they're just that's going to decide, what output states there's going to be. The interesting thing was, at first I had this all apart, and I was kind of figuring out the wiring, because how you have a 3-speed switch here. Think of a 3-speed fan motor. I thought I could just use those 3 relays to like switch on 1, 2, and 3, but the way they had it wired was kind of weird. It wasn't wired simply that way. It kind of had some weird interconnects, so it was going to be way too complicated. So I changed my mind in haste. It actually worked really good though, And I just grabbed that little, like I said, light dimmer I had, and just the first relay goes through that light dimmer just to run this real slow, and then the next relay just bypasses that, and then you get full speed. So yeah, got someone else done. HVACR would say, "Hey man, what's up?" So just doing it live instead of streaming, or I should say instead of clips and editing. But I haven't put up a video for at least a week, I think. Slacking. So, and I know a couple of the guys, that I talk to, they do coding and stuff. So months ago, I was switching from Pick Basic Pro to the C code. So now I'm only using C code for my stuff. So there's my defines and labels for my actual port pins. And my variables. Got all those different ones. All the different functions, This time, unlike the other one, it was reading like, 6 freaking thermistors? I'm only reading 2 here. So I got my analog to digital set up, reading it. I got my temp calculation, which is a subroutine I made, which converts it from that 8-bit value to an actual degrees Fahrenheit. Within a degree or so on the slope, it works good enough for just control and stuff. And then that's just how it reads it from the high byte. I'm just using the high byte out of the 10 bits that they give you. They don't give you 8 or just 16. It's like 10, 2 high byte or whatever it is. I don't know why I have these PIC 16 chips. It's like a 10-bit analog. So I like just using 8 bits because it's 0 to 255. It's just real easy for me. So, and that's all the resolution I really need for this kind of stuff. So I just left Justify and use the high 8 bits, the high byte or whatever. And then that's what I do. So I'm just reading, there's a defrost temperature, which is just a probe shoved in the coil out there. And then the liquid line one, which is the one that's controlling the pump speed. So this one here in my code, I just look for it to go below like 25 degrees. I can adjust it with buttons on there once it's running, but when I first program it, it's kind of turn it on, it kind of just loads these values. So 25 degrees with an 8 differential. So when it hits 25 degrees, it's going into defrost. And I have like a timer with fail-safe timer, and then terminate on temperature. Oh man, when you move this, they added all this new stuff to Windows 11, so you put your mouse in the wrong spot, all sorts of stuff pops up. Can't find my mouse. So yeah, I got a function for high pressure, and basically, since I only have so many inputs, I just used I just break my thermistor, which will shoot my value up to like 250 or something. So if the value goes above here, which I'm never going to read 240 degrees on liquid line normally, ever. So if it hits that, I just know that the high pressure switch opened out there, and then it's gonna I have it turning the pump off, and then high pressure. Oh yeah, it stops the compressor off. So safety. I don't remember if I ever finished all the code. Well, it'll stay in there until that drops below there, so it works. And it just keeps saying that it's in high pressure safety. So compressor start, shut down. There's a sequence, the startup, the pump control. I think I already had that on that, switching speeds. Defrost. It stops my compressor, pumps, or outputs will all be 0, and then starts a timer, and then it's going to start decrementing that. And diff count. Oh yeah, that's just for my. I was like, what the F is that? And I forgot I put that in there. There's another variable. I put it so I could go in there and push some button, and then look later on, see how many times my thing went into defrost. And every time it goes to a defrost, it just increments this counter variable. It's just something I could look at later. And when it goes into defrost, then it's in mode 2 for defrost. It stays there until it terminates. You basically have it keeps coming back to the subroutine because it's in this mode. It'll defrost it, keeps reading that thermistor and counting down the timer. And then a cool thing I did is I think if it's like more than 15, 20 minutes in defrost and the thermistor hasn't hit the termination point of like 32, 33 degrees, then it's going to turn on this freaking other output, which is a contactor down here. And that contactor right there just gives power to the heat strips. So I don't have to like manually switch my system over when it's too cold outside to like heat worth a piss. It's gonna turn on electric elements in that thing. So that's what that does after a while, which is right here. I was using the pulse width modulated output, so instead of a binary digital output, I just telling it full pulse width. Anyway, that's what that is. And then when it basically if timer equals 0 is when that all elapses, and that's when everything reverts back to mode 0 on that output and all this stuff. And then it's going to just do a countdown for an anti-short cycle delay before it leaves there. That's just in case it's a really short defrost. I always want to give it a good 5-6 minutes before the compressor tries to restart. And in the way it kind of, I think in the code, if basically if the if I defrost sensor is above the set point plus the differential, right, it just turns the timer to 0, and that's the only variable I need to change, and then automatically, because of the other code, it's just going to leave. So pretty simple stuff in there. And then I can push the buttons. It says terminated by you. I'm sure I put an MF or something in there. And I have other things. I have a way to override a heater just to test it, and, or there. And then I think I have a function just to override it and just run electric. So it says run electric. So I'm kind of getting comfortable enough with. Don't know everything about C code now, but I mean I'm comfortable enough that I could just kind of get in here, just start typing away on it, just start building up, just looking at it. And sometimes I've actually written quite a bit of code and hit build, and it just did it without errors. And sometimes I'll go and write out some of the stuff, and then it'll just have stupid errors. And some of the stupid stuff that's getting me, which is getting used to, is the equal sign. So when you're commanding like a bit output, like comp equals 0, this is like that one of the defined port bits, right? And the port register, you just set equal. But when you're looking, if something equates to 0 or equates to 1 or whatever, you have to use double equals. So that's getting used to. It wasn't like that in Pick Basic Pro. It was just always just equals. So that's different. So whenever it's equates, you always have to put double equals. And if it's, unless it's like equal to or greater or whatever, which I had to do, something up here somewhere today. Yeah, like right here. The liquid line is greater than or equal to set high point, then you're in pump mode 2. So getting used to that kind of stuff. But I'm getting old, and if I was learning code from scratch, I'd be screwed probably, because I'm over 50, but because I've always liked BASIC and all that stuff, and I meddled with a little bit of assembly and stuff here or there as needed, then going to C code, just have to learn the syntax a little bit. So anyway, I'm going to go ahead and turn it on live. I made a couple changes to it. So see this cable? I'm actually got it plugged in. So it's plugged in. It's successfully programmed, but I haven't turned on. Let's go ahead and do it again. So we're going to hit build and program up here. Build successful. Let's get connected to that PIC3 programmer up there. Erase the chip. Programming. And then it's complete. So basically I just wrote to this deal up here. This is my programming interface. If you look on some circuit boards on HVAC equipment or whatever, you'll actually see sometimes a header pin just like that there for them programming it. So it's just in standby. I'm pretty sure my water heater is still too hot. So I just gotta, whenever this turns on, it just turns on an input. Dang. I've only coughed twice during this. I've had a lot of coughs this week. Been kind of sick, but anyway. Focus. Ain't gonna want to focus. So I'm gonna have to actually override my set point. Where you can see I got the water at 133 degrees already. Just gonna turn it up and then back down just to get it to kick on. Now the output went on. It just turns on a 5-volt power supply, which goes to an input there. Oh, and when that thing's plugged, oop, I got a glitch in the code. Look at that. I wasn't doing that before, but I just made a change. So now I'm gonna have to go and stare at this. What it's doing is it seems like there's a condition that's making one relay output be active, and then another condition that's switching to the other one. Somewhere in this is what I just changed. Changed this from something else to this setup with the switch case. I'll have to stare at that after I'm not live streaming and fix it. But yep, that's the kind of stuff you go through when you screw one thing up in a code. The syntax everything's okay because it's programmed, but it's just in the logic. So why I can see my low speed. So for some reason it's something in here. Something's making it run through this, right? This making this case to where it's turning on this bit output on it for just a second, which that relay ain't gonna like that after so many zillion cycles, right? So if the liquid line is less than set high and the liquid line is greater than set low, then it's in that mode. So the temperature is 105. So something's definitely weird because I think my stock settings was 100, 110. So we shouldn't even be running equal to or greater than. And I can see that the high-speed relay is staying on, which is the one in the middle there, or the left middle, and then the one that's supposed to be low is jumping. It's at 106 degrees. There. He doesn't want to focus. 106 liquid line and coils 50. That coil keep dropping. 106. It should be just on medium because 110 is where it kicks up to high. So it's staying on high. So I gotta look through this and see why these conditions are goofy. Just look at it. It looks like everything's correct actually, but it's gonna be something stupid. I did just make an abrupt rewrote this whole section, and then I went and did the live stream before I even tested the difference. It actually was working before the other way. It was just something I wanted to do different. So anyway, but that is how it works. It gets a little hotter on 9 at 110. It should just be on high, but yeah. So that's not good. Dang, I've had like a dry cough cold this whole week, man. It sucked. Hope I get over it. Oh, see, it hit 110. Now it's just staying on high like it's supposed to. So it's happy with this condition, putting this variable P mode at 2, and so it's staying right here. When it goes to the cases, to set the outputs and then display on my screen. So it should be saying pump speed medium. It should say pump speed high. But anyway, that's something goofy there. Oh, and I didn't leave my pot. I need to add a delay back in here. It's not even reading. That's why it's not reading on my thing up there. It's going through here, but it's not. I need to hold, put a small delay just to read this for like a second, or half a second, whatever, just to see it. But in this condition right here, it is pissed off. So it's, if this liquid line is less than set high and liquid line is greater than, and the reason you have this and statement is because when the temperature is above set low, then it's going to be you know, it's saying go to P mode 2. But if the temperature is way high, it would, at this point, it would still, you know, meet that condition. But you want it to where the temperature reaches a next threshold set point, the second set point, right? That this is no longer viable, because in the liquid line, you know, it says the liquid line has to be less than the high set point, but above the low set point. Then it's in this condition, which is low speed. When it gets temperature goes even hotter, then this is no longer viable. It should be up here, but for some reason, when it was first booted this thing back up, it started it. It's latching on my high speed and blinking on this one. So there's some weird glitch. And sometimes, again, it could be somewhere where you put a, like I said, a equals instead of a double equals, where it needs to be. Like it equals, you put that when you're telling it to, this is the output or the variable. But then when you're doing a comparison, like, you know, it's like a double equal sign if it equates, unless it was the greater than or equal to, which I think that's right, unless that is what's wrong. But it doesn't make any sense. So I'll have to look at that and figure that out later. But that's pretty much just what I've been doing. Kind of ripped out what I had and kind of threw this stuff all in there. And it's kind of work. It's not perfect. And I redid. Whenever you redo something a few times, it starts getting messy in a hurry. But it's not too bad. Got my voltage regulators up there and 24 volt AC there. The relays. Those relay boards are cool, man. I can't even build them for what I could buy them all put together on Amazon, so I just buy these things. They take a logical input, run on 12 volts DC, and then just have a logical input, which I could come right out of my processor. So it's pretty cool. And that's just, like I said, my pump relay up there, so I don't cook one of these little ones. Temperatures. See how the liquid line temperature is staying real high, so it's staying happy on high speed now. That's because the whole water heater is full of hot water at this point. Because once it keeps pulsing the water back from the low to the top of the tank, eventually the hot water it pushes it down into where I no longer feel tap temperature, but hot. And like right now, I can tell it's almost too hard to hold on to that, so it is close to 130, even down there. So I'm gonna go ahead and I also have this little Wi-Fi thing, so I could turn this thing off by remote. It just powered up my thermostat, but this thing will stop in a second. I'll have to go mess with the code. There it goes. And a short cycle delay every time a compressor stops. I don't know why this thing doesn't work. The camera does not work good on this thing, YouTube live streaming, like it does if you're just recording with the camera. I imagine maybe it only uses one of the lenses instead of switching between the three for close up and wide and whatever you call it. It's probably just using one of them. I don't know. Kind of hard to tell, but anyway, that's about it. So just a little update. If I keep going, I'm just going to ramble. But now I got to put my thinking cap on and read through all these lines of code. With that, we'll catch you guys later, man. I'll post some updates later. Hopefully getting to some more of my projects going again eventually. All right. Don't forget to like, subscribe, and share. Catch you guys later.